Welcome to video 8.4f, another proof involving proportions with similar triangles. This proof will actually help form the basis for the altitude to hypotenuse theorems in chapter 9. So here's example 7. Given that triangle ACB is a right angle and that CD is the altitude to the hypotenuse, I've also included right away, this is a right angle, this is a right angle, just to help simplify the proof. So I'm going to put that as a given. Prove that CD squared equals AD times DB. Again, whenever I see that multiplication or product, I'm going to go backwards and change it to a proportion. So I went backwards and changed it to CD squared. I've got CD on the same diagonal, and AD times DB, I've got that in the same diagonal. So this is the proportion I care about. After that, I go and look for triangles. CD and AD happen to involve sides of this left-hand triangle. DB and CD happen to involve sides of this triangle on the right-hand side. So if I can get this triangle and this triangle to be similar, game over. Now to get this triangle and this triangle to be similar, it's a little bit complicated. I've got to go through a bridge of the big triangle, because the big triangle is the one that's going to be sharing angles with those left and rights. So that's how I've got my proof set up. Big triangle similar to left triangle, big triangle similar to right triangle, use transitive to get left similar to right, and then game over. Okay? So let's do the proof. I've already got the given down there. So now I'm trying to get the big triangle to be congruent to the left triangle. Well, I know that the right angles are congruent, so I can say in the big triangle, angle ACB is congruent to angle ADC. That was given. Or I'll say if right angles then congruent, excuse me, then they both share angle A. Angle A is congruent to angle A, that's by reflexive. So I've got my angle, Now I've got the triangle similar. So triangle, I'll go ABC is similar to triangle ACD. Just be careful with your ordering of those letters, and that would be by angle similarity. So that's big to left. Now I want to get big to right. Okay, so for big to right, they both share a right angle. So angle ACB is congruent to angle BDC. And I'll say if right, then congruent. Then they both share this angle B over here. Angle B is congruent to angle B. That's by reflexive. So now they're similar by angle. So now I've got triangle of the same ordering, ABC. So ABC going over here, so that would be the angle not of interest. That would be angle CBD by angle similarity. And now, just to show you, I've got ACD jumping to ABC, ABC jumping to CBD, so I can start here and end there. So now I've got triangle ACD is similar to triangle CBD, that's by transitive. And now, once I've got left triangle similar to right triangle, I can go in backwards and get this proportion. So I'll write it down. CD over AD equals DB over CD. Let me just do a check of my lettering really quick. So I've got last two letters here over first and last equals last two letters here over first and last. That makes sense. And finally, now I can, oh, I didn't put the reason. If similar, then corresponding sides proportional. And then I'm just going to cross multiply. CD squared equals, let's do the same order, AD times DB. Cross multiply. Whew! And that's exactly what I wanted. So there you have it. A proof which is going to form the basis of the altitude to hypotenuse theorems later on in Chapter 9.